Hello and welcome. I'm Matthew, and today we are going to make our first enhancement to the MVS 3.8 system that we built in my previous video series on following Jay Mosley's instructions to install and sysgen our MVS 3.8 operating system on our emulated Hercules mainframe. So let's log on and talk about what we're going to do. One of the programs we installed is the review front end, RFE. So if we go into RFE, it's an ISPF-like environment that you'll primarily use for editing data sets, source files, job streams, those kinds of things. But it also provides several utility functions. One of those functions, like ISPF, is under Utilities, so 3, and option 8 is our outlist. So we'll go into the outlist. This allows me to view the output of jobs whose output is spooled on the system. So when I use an output class that does not go directly to a real printer and then immediately gets purged from the system, it sits in the output queue inside of the job entry subsystem. So what you can see here is I'm able to see jobs that begin with my username. And we'll soon find out I'm not able to see any other jobs. So let's go ahead and experiment with that a little bit. We'll go into the dataset list. I'll look at my datasets. And let's just make a dummy job in my control dataset here. So I'll browse that. I don't have anything here yet, so let's create a new job. We'll just call it dummy. And let's say we'll name that M. Wilson D, and that's going to be a job. And we'll make sure that we're going to our held output queue, so it'll show up in our outlist. And this just needs to be a simple job that does nothing. So we will run the IEFBR, I think I'm remembering that correctly, 14 program, which quite literally does nothing. Okay, so I have this job. Let me submit that. This will run this job. Okay, submitted. Now let's look back at that output queue. One of my favorite features of this RFE and review environment is that, like the split command in ISPF, I can actually start another session. And you can see I'm in session 2 now. Actually, I find this to be even better than ISPF because it actually gives you the session number in review. So now I can swap between my sessions. I can swap back to 2. I can swap back to 1. The F9 key will also do the swap for you. And you can actually have more of these. So here's 3, right? But we only need 2 for now. So I'm able to go to that outlist. So utilities, and then it was outlist 3.8. And this is convenient because just with F9, I can swap back and forth between tweaking and changing my job, fixing source code if there's a problem or whatever the case may be. I hit F9 and now I'm back over, and just with an enter, it'll refresh this list and I can view my output. So anyway, RFE tip, if you didn't know, you can start sessions with actually F2 or the start command, and then you can swap back and forth with the F9 command. So as you can see, I ran that job and I can see it because it begins with my username in Wilson D. So let's go back and change that to something else. Let's call it maybe my job. Now I'll submit this job, and you can see my job was submitted. Okay. I'll swap back over with F9 to the outlist. I'll hit enter just to refresh it. And I don't see that job. I see my old job because it starts with my username. I don't see my job, the job named my job, because I'm only seeing jobs that begin with my user ID. Now, if I leave RFE here, we can exit out of this. Remember, we also installed the Q command. So if I run Q, which by default is showing me jobs that begin with my name, if I type HO for held output, now I can see all of the held output on the system. And one of those held outputs is that job named my job. And I'm able to view that job. So I often use my username as the beginning of the job name and then just with a letter after it. But I'm also often downloading jobs from JCL files on the internet to maybe install other software or try something that somebody else has tried. And if I don't always remember to go in and change the job name, it's a little bit annoying to not just have it conveniently there inside of the RFE 3.8 output. Now, it turns out this RFE out program knows how to view all of the jobs in the JES2 output queues, and it will let you do so if you have the appropriate permissions. I believe it shows you the option if you have the operator user class, but it needs to know that you are using JES2 as your job entry subsystem so that it knows it can directly communicate with JES2 instead of just running the TSO command behind the scenes to list jobs. And the TSO command only shows you the jobs that start with your username. So the problem is, as our MVS system stands, the way we installed it, the data structure that is available for programs to figure out what subsystem is running does not have the symbol defined for the subsystem ID, and our JES2 version is not new enough such that it sets that data structure to version 2. So RFE here doesn't know that it's running on JES2, therefore it doesn't know that it can pull all of the jobs if we want it to. So the good news is, if I switch over to the web browser, Kevin Leonard on his site, j76.org, maintains some interesting information on Hercules and different operating systems and JES that you can run under Hercules. And one of his user modifications on the site here is TJES 801. It sets the SSCT SSID and SSIB SSID to JES2 to indicate that the JES2 subsystem is the running subsystem. So with these set to the value 2, that RFE output list will give us the option to view all of the job output on the system. So that's exactly what we want. Now, if we look at this SSCT SSID, this is actually something that exists on current modern MVS versions. ZOS 2.2 documentation here is what came up when I Googled for it. There's this SSCVT data structure that's available, control data set. And we can look here, and I probably scrolled by it. Where'd it go? I'm looking in the wrong column. Here we go, right? So SSCT SSID. And there's a defined value here that it's 2 when JES2 is running. So this is standard MVS stuff. It's just our system is a little bit too old for this to be in there right now. And so what we're going to be able to do with this modification is set that, and then RFE will know. So this is a modification that loads through SMP, the system management program. And the first thing we're going to do is look at the cover letter. And so this has some information. It's the name of the user mod, TJES 801. There's some version information. It applies to this product. But what we're really interested in are the prerequisites. So these are the other user mods or PTFs, program temporary fixes from IBM, that must be in place before we're able to apply this user modification. All right, so what I like to do first is check that I have all of the necessary prerequisites. I think we'll download this later, but the job stream we use to install this, I think, is just a one-shot receive and apply. If we received separately, we could have the system analyze some prerequisites for us and then apply it. But we can just directly check these. And we use the SMP program to do that. So let's go back to our system, log back on here. Now, the first thing I'm going to do, let's go back into review. We have from our installation the sys2 proclib data set. If we look at this, One of the catalog procedures in here is the SMP. I think APP is supposed to mean apply, perhaps. So the SMP apply catalog procedure. We're going to edit this. So this runs the SMP executable, the actual SMP program. But that program needs quite a few data definitions, data sets defined, a lot of input and output, as well as where is the system you want to modify, where is the control data set for SMP. So it's nice to use this catalog procedure because it already does all of this work for us, right? It matches our system and all of the output objects in our system. So we'll always be using this catalog procedure to run SMP. The one piece we don't have is the SYSLIB data definition here. It does not have the HASP, Houston Automatic System Processor, basically the original name of what turned into JES, at least JES2, the job entry subsystem. We need to add the HASP source to our SYSLIB DD here. So we'll just add that to the SYSLIB concatenation. Let's add a line, DD disposition shared, and the DS in here is sys1.hasp src. This will be important because these user modifications we're installing are modifying our JES2 to set that value to 2 when it runs. So we'll put that there, and I'll just leave that there forever. And now any of our SMP activities is also able to do patches to JES2. Okay, so now that we've done that, let's write a job to actually use this procedure. So we'll go back to my MWilson control data set and maybe make one called SMP job. And this will just be a pretty straightforward, I'll call it MWilson S. It'll be a job, message class is X. And we will run the SMP APP catalog procedure. And we only need to define one data set here, which is our SMP control data set. And this will be our input. So these are the commands that we're running in SMP. I'm going to switch back to my web browser. And on BitSavers, we have the System Modification Program Systems Programmer's Guide. And this is the user manual for SMP. So if it loads, looking at the table of contents, we will see, if we go down, installation and use, here we go, control statements. So we have all the control statements that we're able to provide, and one of them is list. And list gives us information about our system. So what I want to do is use the list command and look in our control data set for the prerequisites that we want to know if we have on our system or not. So I'm going to copy that list. And let's go back to our system here. So we want to list CDS. And then I'm able to give it a list of system modifications that I want. So let's see if I can paste that in here. Nope, let me go back and grab it again. That's not working. Sorry, bear with me here. C, insert. There we go. Okay. And these end with a period. So include the period at the end of there. And that's the end of our list. Whoops, save. Okay. So we're using the SMPAPP catalog procedure, and we want to list from the control data set anything the system knows about these system modifications or user modifications. So let's submit that. Okay. Let me start again, and we'll end up over here, and we can go to our outlist 3.8. And there's our job. So let's select that. And there's going to be quite a bit of output about all those data sets that the catalog procedure is working with. It allocated them, it kept them, it got rid of them, blah, blah, blah. And it looks like we made a mistake. Syntax error in control statement at column 12. All right. So let's get rid of that output. Let's swap back over with F9. And I think I need the word sysmod here. So let's do insert sysmod. Oh, I don't have, I need to fix my terminal so that get rid of the spaces at the end of the line so they're blanks, and then insert sysmod. Okay, let's try that again. Submit. F9 to swap. Look at that output and see what we got. Yeah, that's better. So for each one of these we requested, we're going to see some information about it. So this particular sysmod has been superseded by a later sysmod that we installed. That's fine. So this is a prerequisite, but because it's been superseded, whatever we installed that superseded it will provide, will satisfy the dependency on that particular sysmod. We can see others that have been installed. PTFs have been received and applied, so those are in our system. If we go ahead and go all the way to the bottom, here we go. Select summary report. The summary report will tell us the ones we did not find. So UZ77164 was listed as one of the prerequisites of, let me switch over, of this job. There it is, UZ77164. But that's not currently applied to my system. So UZ77164. The next question is, well, where do I get UZ77164? It turns out, I'm going to go ahead and purge that output, swap back over. It turns out that UZ77164, let me just delete the rest of these. It's a PTF that was on that tape of PTFs that we received during our installation, but it's not one that we actually applied to the system. So if I look in the PTS, which is the PTF temporary storage, it's the data set that's essentially the holding tank of all of the updates that I can apply through SMP, but that haven't necessarily been applied yet. So if I list in the PTS and look for sysmod UZ77164, let's submit that job. Okay, and look at the output. Let's just go straight to the bottom. Okay, so you can see that UZ77164 is a PTF. We have received it. We just haven't applied it to our system yet. So before I'm able to install our user mod that we ultimately want to install, we need to finish installing its prerequisites. This is one of them. If I hadn't received this, I'd maybe need to search the internet to find a source for UZ77164. But we have it, so let's go ahead and apply it to our system. So I'm going to change this job, and instead of listing, we're going to apply, and we're going to select that sysmod. Now, there's another prerequisite that isn't listed. I don't know if it was just a mistake or if there was a reason not to explicitly list this, but we also need UY02859. It turns out this sysmod, UY02859, which again, we've received but hasn't been applied to our system yet. This is the sysmod that actually adds those symbols, SSCT, SSID, whatever they were called. Without this, we will get an error for that symbol not being found. So through experimentation, I found that this sysmod is required in addition to the listed prerequisites of the sysmod that we want. So the way we apply these is just with the apply command, and then we're going to select the ones we want to apply. And these will select out of the PTS because we always apply out of the PTS. So let's run, let's run that job. Save that just in case. Run that. Let's see what happens. Switch back to my output. It's still executing. This can take a little bit of time because it's actually now making those changes and then recompiling and relinking parts of our system. So it finished. Let's look at the output of that. Okay, we got the condition code of 0. So that was successful, 2.9 seconds. And you can see the input to all of this. And if we go past all the Jez2 stuff, okay, so it ran the link editor here. So it's linking the new output objects. There were some assembly changes to the source code. So this is all the work that SMP is doing for you to apply the changes defined in those PTFs. And then down at the end here, you can see, okay, so we applied UY02859, and we applied UZ77164, which happened to have these prerequisites, which were satisfied, so it was able to apply. And here's information about other superseded stuff. Okay, so highest return code is 00. That's perfect. So that looks like that's successfully applied. So I'm going to purge that job. And we may as well clean up these other ones while we're here. Okay. So those are the prerequisites. So we learned how to list the applied sysmods. And in fact, now if we do that, let's sysmod. I need to change my C3270 preferences to avoid this problem. Sysmod. Now those should show up as applied, and they'll be part of our system. Let's prove that to ourselves. Yeah, we got 0, so everything was found. Let's just go down to the bottom. Perfect. We don't have the list of things not found, and if we scroll up, we can see that both of those are received and applied. Okay, very good. So let's, we can just exit out of all of this for now and log off. Let's go back to the web browser. And now that we think we're ready to apply this, I'm going to download it. So let me copy that link and go to my shell, go to my downloads directory and get that. Okay, and let's unzip it. All right, so what we got is a JCL file. And it looks like it is going to use the SMP REC catalog procedure, which we do have, so that's fine. And it will receive all of that, and then here's the actual source code changes it's receiving. Okay, the exec step is going to use the SMP apply catalog procedure. We have that, and we know we have that because we already made the modifications so that it can apply changes to that HASP source data set as well. So this looks good. We can go ahead and run. Actually, before we do that, let's go back to the top and just confirm class A, message class A. I'm going to change this to message class X so that we can just have that in our held output queue. And we might have a problem with an 8 meg region. I find I either need to go 4 megs or smaller or significantly more than 8 megs. There's something right around the 8 meg size where the system is not able to allocate space for it. Don't quite understand why, but That's okay. We'll just change that to 4. Replace 4, and I suspect this will run just fine. So let's save that. And remember, we have the submit file, so we can just go ahead and submit that tjez801.jcl. So that's submitted. If we cheat and look back on our MVS console, you can see this job was submitted. It's running. The first step got a 0. That's good. Next step got a 0. That's also good. And the third step just got a 0. So that's also good. So it looks like this applied successfully. So now that we've applied that, we need to re-IPL the system and rebuild the link pack area. And that is because some of the changes we made are to modules that live in that link pack area. In fact, Moshix, just coincidentally enough, a couple days ago, did a video on the manual IPL process of that TK4- system. And among other things, he describes what the link pack area is and what's happening when you clear the link pack area. So I'll try to remember to link to that video in the description if you want to learn a little bit more about what this whole LPA, CLPA thing is. Regardless, to do that, we need to re-IPL. So let's stop our system. We'll stop TSO. And with TSO stopped, we can stop VTAM with znet, quick. All right. Now we can stop JES2. And now we can do the end of day processing and quiesce the system. Okay. Back over in Hercules now. I can go ahead and I can quit Hercules and start back up, but then I have to reconnect my consoles. I think I can just go ahead and re-IPL the system now. So IPL 150. And then over on my MVS console, this is where you normally hit enter during a normal startup. But because we want to rebuild that link pack area, we'll reply 0 and tell it to clear link pack area. That rebuilds the LPA. And now we'll proceed like a normal startup. So we can just do a warm start of JES2. We hit F12 when we first get that message waiting prompt because we have a PF key set up to run our display area commands to go into roll delete mode. And we're started up. So let's go ahead and start net. That'll bring VTAM up. And now I'll switch back over to my TSO window. We'll log on to the system. We'll start up RFE. Now if I go utilities outlist, aha, look at that. RFE is now telling us we can use the st star command to see all jobs. So I'm seeing the jobs that start with my name, like usual. But if I say st star, now I can see all of the held output in the system and running jobs. So I'm able to see my job. I'm able to see the job that we ran to apply that PTF, or the user mod. So I should be able to select this and see its output. Yep. And I should be able to purge it. Oh, I lied. I can view them, but I'm not able to purge them. Maybe something to investigate for another day. Nevertheless, I do find it very convenient to be able to view all of the job output on the system, all of the held output, and not just the jobs that begin with my name. So I hope that was interesting. Hope you learned a little bit about SMP and how you're able to query the system for installed sysmods, PTFs, user mods, as well as apply some extra PTFs that we received during system installation but have not yet applied to the system. And we also made the RFE output list a little bit more useful for us. So thanks for watching, and we'll see you in the next video.